Hello. Now it's okay. Hmm. So in the last class, I told you the refraction through spherical surfaces. Refraction through spherical surfaces. Okay. So we have derived one formula. This formula we have derived, and finally we got this. N2 by V minus N1 by U is equal to N2 minus N1 divided by R. So what was the case here? The object is placed in a medium having the refractive index N1, okay, and the light ray is going to the medium having the refractive index N2. U and V, U is the object distance and V is the image distance. You can see here is the image, and R is the radius of curvature. What is radius of curvature? The distance between the pole and the center of curvature is the radius of curvature. This formula we have N2 by V minus N1 by U is equal to N2 minus N1 by R. Okay. What is N2? What is N2? Refractive index of the medium in which the light is going. You can see here light is going in this medium, N2 medium. And N1 is the refractive index of the medium from which the light is coming. So light is coming from this medium, N1 medium. Hmm. Okay, so we will solve this question now. We will solve this question. They are asking find the position and the nature of image formed. This is the object placed, this is the principal axis, and this is the spherical surface. This is the spherical surface here. Here is the spherical surface, okay? And this is the medium under spherical surface. And this medium is a glass medium having the refractive index 1.5. And here is the air. Here is air. And this air have the refractive index 1. And this object is placed at a distance of 30 centimeter from the pole. And center of curvature is at a distance of 10 centimeters from the pole. And this is the principal axis. We want to find the position and the nature of the image. Position and the nature of the image. Very easy. We have this formula N2 by V minus N1 by U is equal to N2 minus N1 by R. What is N2? Refractive index of the medium in which the light is going. So now you can see object is placed here. So from this object, the light will go in this medium. So N2, you will take the refractive index of the glass. So here, the value of N2 will be 1.5, and N1 is the refractive index of the medium from where the light is coming. So light is coming from the air. So N1 you will take 1. N1 you will take 1. And this is the object distance. This is the object distance. So this object distance is 30 centimeter. One thing I told you that in the direction of incident ray, that direction will be positive. If you are measuring the distance in the direction of incident ray, then that distance you will take positive according to the sign convention. So object is here and light is going in this medium. So the incident ray direction is this. Incident ray direction is this, means this direction is the positive direction and this direction is the negative direction. Okay. This direction is this direction is positive. Why? Because this is the direction of the incident ray. So now this object distance is distance from the pole to object. So I told you we will measure all the distances from the pole. So for measuring this distance, you will move from pole to object, means you are moving in this direction. So this object distance you will take negative. So you will take minus of 30 centimeter. Now what is this? This is the radius of curvature. Now to measure this distance, you will move from pole to center of curvature, means you will move in this direction, and this direction is the positive direction. So radius of curvature you will take plus 10 centimeter. Is it okay, Fawaz, Nida and Hamza?
Yes, sir.
Very good. Now just apply the formula and you will get your answer. You actually a position of the, what they are asking, position of the image. So position of the image is basically V. You can apply the formula and you will get the answer. Very easy. You have to just put all the values properly. N2 by V, N2 by V, N2. See what is N2 here. N2 is 1.5. So put here 1.5 by B. V we want to find. So V we will put V minus N1. N1 is 1. What is U? Minus 30 is equal to N2 minus N1. N2 minus N1 means 1.5 minus 1. And divided by radius of curvature. That is 10. Okay, all of you just Fawaz and Nida, just try to solve it by yourself. I am giving you 2 minutes. Find the value of V fast. I want to see whether you can do this kind of calculation or not. Hamza, you also try. You have to find the value of V. Okay, I am solving. Now check your calculation. Check your calculations. I am just solving. So you can write this value. This is 1.5 minus 1. It will become 0.5, and this is divided by 10. You can remove this point and increase 1 0, and then you can cancel it out. It will become 20. So finally you will get 1 by 20. 1 by 20 you will get 1 by 20. So you will have 1.5 by V plus 30, 1 by 30, 1.5 by V plus 1 by 30 is equal to 1 by 20. Further you will solve it, you will get 1.5 divided by V is equal to 1 by 20 minus 1 by 30. Now solve this. Take the LCM of 20 and 30, you can take 60. So here it will be 23 60, 30 2 60. It will become 1 divided by 60. So you will have 1.5 divided by V is equal to 1 by 60. Okay. Now you will get V is equal to 60 into 1.5. You will get plus 90 centimeter. So this is the positive sign here, and 90 centimeter. Positive sign means the image is formed in the direction of the incident ray. So this is a pole, and direction of incident ray is this direction. Means somewhere here you can locate the image. So you can say the image is formed at a distance of 90 centimeter like this. 90 centimeter. Now real and virtual, how we will see real and virtual. How many of you got the correct answer? Fawaz and Nida and Hamza? No one? Okay, fine. So now, okay, no problem, Fawaz. And Hamza, what about you? Okay, no problem. Now see, uh, it is clear the image is formed this side, but now we will see whether the image is real or virtual. What is real image? When the rays are actually meeting, real image. When the rays are appearing to meet, we are getting virtual image. Okay. So now here we will see what is happening. So this is the object. So from this object, suppose the ray is going like this, and this ray is going from air to the glass. Refraction will take place. For showing the refracted ray, we draw the normal. This is the normal, and I told you the normal will pass from the center of the curvature. So this is the normal. Okay. After that, this air is the rarer medium as compared to the glass. So this ray is moving from rarer to denser medium. It will bend towards the normal. So you can say this ray will go like this. Okay. Another ray from this object, suppose like this, okay, will be normal to the surface like this, and it will pass straight. There will be no deviation. Earlier also I told you. So here both the rays are meeting actually. So image will be the real image. Real image, okay? But not every time you will draw the ray diagram. So note down one thing. If the sign of U and V are opposite, then real image will be there. You can see here the sign of U is negative and sign of V is positive, opposite sign. So we are getting a real image. If the sign of U and V are same, then you will get virtual image. Virtual image. Remember this point? Okay. So without drawing the ray diagram, you can just identify whether the image will be real or it will be virtual. Okay. Take the screenshot, Hamza, Nida, and Fawaz.
Sir, in exam we should not draw.
Hmm?
Sir, in exam we should draw or not?
Actually, na, in exam, na, if you will draw, it is better if you know. Suppose, for example, if you don't know. Suppose, for example, if you don't know, then in that case, you have to remember this. You can write this statement there, okay?
Okay.
But if you know, then you should draw. Then, Hamza, after this, now we will discuss lenses. So, what are lenses? What is a lens? So, basically, a lens is a transparent medium. A lens is a transparent medium bounded by two surfaces, and at least one of the surface must be or should be spherical. What is the meaning of spherical surfaces? Concave surface and convex surface are spherical surfaces, okay? So if one of the surface of the lens, one of the surface is either convex or either concave, then you can say the object is lens. So you can see here the definition of lens. A lens is a transparent medium bounded by two surfaces. Bounded by how many surfaces? Two surfaces. Two surfaces. one of which must be spherical. Remember this. One of which must be spherical. Spherical means either concave or convex. Spherical means either concave or convex. Okay, so we will define the lenses. These are the lenses. This type of lens is known as the concave convex lens. Why I am saying this is a convex lens? You can just see here. Talking about this surface. Talking about this surface. Fawaz, can you tell me which type of surface is this? Is this a concave surface or a convex surface? This surface.
Sir,
And you are just watching this surface from this side. Convex, right? Convex. Suppose now you move to this side and you are watching this surface. This surface. So this surface is a concave or convex? Hmm? This surface, this. Nida, you tell. You are watching this surface from this side. This is a bulging outward surface. This is a bulging outward surface. Hmm? Convex surface is a bulging outward surface. Remember. So this is a convex lens, and here both the surfaces are convex. Now this surface is a bulging inward surface. This surface is a bulging inward surface. So what I told you, a lens is a combination of two surfaces. Here two surfaces are convex. Here two surfaces are concave surface. This is a concave surface, bulging inward concave surface. So this is a concave lens. This is a concave lens. One more point we can write for the concave lens. This lens is thick in the middle, okay, and thin at the edges. So this convex lens, thick in middle, and for the concave lens, thin in the middle, or you can say thick at edges. Okay, so thin in the middle, thick at edges. So broadly, we define the lenses, and mostly we will use these type of lenses where both surfaces of the lenses will be convex or either concave. But there are further classification also. Further classification. So if this type of lens you will get, both surfaces are convex surfaces. Both surfaces are convex surfaces. Then you will say this is a biconvex lens. This is a biconvex lens. Bi means two. Two convex surfaces are there. Now you and now this, see this. This surface is a convex surface. Bulging outward, okay? Bulging outward means convex. and this surface is a plane surface. So this is known as the plano-convex lens. Plano-convex lens. Okay. Now see this. This surface is a convex surface bulging outward. Bulging outward. Bulging outward means convex. Now see this surface. This surface is a concave surface bulging inward. Concave. So this lens is known as a concavo-convex lens. Concavo-convex lens. Concavo-convex lens because both the surfaces are here. Now concave lens further classify. Here both the surfaces are concave surface. This is also a concave surface. This is a concave surface. This is a concave surface. Cave. C-A-V-E, cave. So this is a cave, na? Looking like cave. Concave and concave. Now this is concave and this is plane. Now bulging outward, convex. This is bulging inward, concave. This type of lens is known as biconcave lens. This lens is known as plano-concave. This lens is known as convexo-concave. Convexo-concave lens. Take the screenshot. Okay.
Sir, this both convexo and concave lens are same, right? You draw.
This one.
Yes.
You are talking about okay, just a minute. You are talking about this lens and this lens.
Yes, yes, sir.
No, these are not same lenses. Now you can just see here. You can just see here why I have written here convex. See, See, this lens is thick in the middle, and thick in the middle is convex lens. So basically, overall, this lens will be the convex lens. That is why I have written here convex lens. So overall effect of this lens will be of convex nature. This name na here written will be the main name of the lens. Now see here, this lens is thick at the edges. Thick at the edges. Now which lens is thick at the edges? Concave lens is thick at the edges. Understood?
Yes, yes, sir.
So I can understand your question. You are right. Very good question. You can say that here also a concave surface, here also a means in this lens there is one convex surface, there is one concave surface. In this lens there is one convex surface and there is one concave surface. So sir, we can say both these lenses are same. No. See the structure. This lens is thick in the middle, and the lens which is thick in the middle is a convex lens we defined earlier, thick in the middle. And see here, this lens is thick at the edges. So thick at the edges we defined earlier as a concave lens. Apart from that, here surfaces are same, here also the surfaces are same. Now if you will see the structure, okay, if you will see the structure, then you will find that this whole lens will behave or equivalent to the concave lens. So that is why I have written here, this is the classification of the concave lens. Overall nature of this lens is a concave. Okay. Take a screenshot. Okay. Okay. Now we will discuss center of curvature and the radius of curvature for lenses. Before that, I want to tell you something about the mirror. So in case of mirror, polish is on the bulging outward side and light will enter into cave. So basically this is a concave mirror. This is a concave mirror. I told you that the concave and the convex mirror are the spherical mirrors. Why these are spherical mirrors? I told you also that because this is a part of a sphere. Okay, when you will complete this like this, it will become a sphere. You will complete the sphere of this. I am not making it correctly, but try to understand what I want to say. Basically, if you will complete the sphere, you will get the center of the sphere, and that center of the sphere is known as the center of curvature of this mirror. And this is the radius of the sphere, and radius of the sphere is known as the radius of curvature of the mirror. Now, see the lenses. In this case, in case of mirror, there is only one radius of curvature, there is only one center of curvature, because there is only one spherical surface. But in case of lenses, we have two spherical surfaces. One spherical surface is this, another spherical surface is this. So there will be two radius of curvature and there will be two center of curvature. So for this spherical surfaces, when you will complete it, when you will complete the sphere of this surface, so there will be the center here, C1, suppose. So for this spherical surface, here will be the center and this distance will be the radius of curvature R1. And for this surface, when you will complete this, the sphere of this surface, means this surface, so center you will get somewhere here. Suppose that is C2. And this distance will be the radius of curvature for the second surface. Now you can see in case of the length, there are two center of curvatures and there are two radius of curvature. Here also, in this case also, for this spherical surface, when you will compare the complete the sphere like this, so here you will get the center and here you will get another center and this will be the radius of curvature R1 and for this will be the radius of curvature R2. Radius of curvature for this surface. One more thing I want to tell you, principal axis. So the principal axis here is the line joining the center of curvature. Line joining C1 and C2 is the principal axis. So principal axis you can define principal axis, line joining C1 and C2. C1 and C2 are center of curvature. Center of curvature. R1 and R2 are radius of curvature. Radius of curvature. So what is this? This line is the principal axis. In short, I will write principal axis as P axis. This line also, line joining C1 and C2 is the principal axis. So this is also the principal axis. Okay, so if you have this lens, okay, if you have this lens, so in this case, how you will define the principal axis? I told you that the principal axis is the line joining the center of curvature, one center of curvature 1 and center of curvature 2. But for this spherical, this is a spherical surface. For this is a spherical surface and for this spherical surface, there will be the center. Obviously, there will be the center. Suppose this is C1. This is a spherical surface. So for a spherical surface, there is a center. But this is a plane surface. Will there be a center for plane surface? There will be no center for plane surface. No. Now for defining the principal axis for this type of lens, what you will do, you will draw a perpendicular from the center to the plane surface like this. You will draw a perpendicular like this, okay, from the center. And you can extend this also. So basically this line will be the principal axis. Okay. If you have this kind of lens, if you have this kind of, so in this lens also, what you will do, this is a spherical surface, this is a spherical surface, and this is a plane surface. For a spherical surface, so you will complete the sphere this side, so center will be, suppose here will be the center, C1 suppose. And for this plane surface, there will be no center. So for defining the principal axis, what you will do, you will draw a perpendicular from center of curvature to the mirror, and that line will be the principal axis. This is the principal axis. Now talking about the radius. So this is C1 na? So for this surface, R1 is the radius of curvature. What will be the radius of curvature? Distance from here to here will be the radius of curvature. This distance, okay? This will be R1. This one. This will be R1, okay? And for this surface, this will be suppose R1. Now what is the radius for this plane surface? For this plane surface, radius you will take infinite. For this plane surface, radius you will take infinite. Understood, Nida, Fawaz, Hamza, what I told you? Okay. Please take the screenshots. These are very basic things and very important things also. Okay. Okay. So lens is a combination of two surfaces. At least one of the surfaces, must be spherical. Spherical means either concave or convex. So mostly now we will use this type of lens where both the surfaces either will be convex or concave. And simply we call this lens as a concave lens, a convex lens. This lens as a concave lens. After this, we will discuss what is optical center. So, what is optical center? So this is for the first we will define for the convex lens. This is a convex lens. So this is a principal axis. And Optical center, a point on the principal axis of a lens through which a ray of light passes undeviated. Okay, and in our syllabus, one thing I want to tell you, in our syllabus, we will study thin lenses. We will study thin lenses. Thin lenses mean the thickness of lenses is very, very small. Okay, so basically, this definition we are using is for thin lenses, but in our syllabus there are only thin lenses. Okay, if lens is thick, then obviously there will be some deviation. So center of what optical center is a point when the light rays passes through that point remain undeviated. Okay, so this will be the optical center. Optical center. Now for the this is the convex lens. Now this is the concave lens. Optical center. Okay. What is this? Principal axis. And remember one more point, not necessary that this optical center will also be the geometrical center of the lens. That will depend upon the radius of the curvature of both the surfaces. Okay. So basically you have to remember optical center is a point when a light ray passes through that point remain undeviated. Simple. Okay, take the screenshot. Okay. Okay. Hamza, are you taking screenshots? Hamza? Okay, so this is the concave, for the concave lens, optical center is this. Okay, fine. So now we will discuss the focus of a concave and convex lens. Focus. So in case of the lenses, there are two optical centers. There are two center of curvature. There are two radius of curvature. So there will be two focus. There will be two focus. So in case of lenses, there are two focuses, first focus and the second focus. So we are discussing the focus. And we are discussing in focus, we are discussing first focus of a convex lens. Of a convex lens, we are discussing the first focus. So now see what is first focus. So this is the principal axis. This is a lens. This is a convex lens. Okay. So for defining the first focus, suppose this is the object. This is the object placed here. And from this object, if the rays of light are like this, okay, the rays of light are like this, and after passing from this lens or after refraction from this lens becomes parallel, so this will be the first focus, f1. Remember this. For a concave lens, how we will define the first focus? If rays of light, just wait, okay? Okay. Now, see, if the rays of light are just going towards a common point, these rays of light are just going towards a point, a common point, this is a common point, and after refracted from the lens becomes parallel, after the refraction from the lens becomes parallel to the principal axis, so this will be the first focus. This will be the first focus in case of the concave lens. So these rays are just going towards a point. After refraction through the lens becomes parallel to the principal axis. So this is what? This is the principal axis. This is the principal axis. This is the first focus. Now second focus. Second focus is more important, and this is also known as the principal focus. Principal focus. So what is principal focus? Principal focus is a point when light rays parallel to the principal axis after refraction meet at that point. Suppose there are light rays like this. First light ray, this ray is parallel to the principal axis. Another light ray parallel to the principal axis. Another light ray parallel to the principal axis. Okay. These rays are parallel to the principal axis. After refraction from the lens, will meet at a common point. Will meet at a common point. And this common point is known as the principal focus. This common point is known as the principal focus. So this point is known as the second focus or the principal focus. Okay. This is principal axis. So light rays are parallel to the principal axis after refraction from the lens, meeting at a common point known as the principal focus for the convex lens. Now the story is different for the concave lens. Rays are coming parallel to the principal axis. Rays are coming parallel to the principal axis like this. Coming parallel to the principal axis. Okay. For the concave lens, you have to wait. Okay, now see, these rays are parallel to the principal axis. This is the principal axis. Principal axis of what length? Of concave lens. These rays are parallel to the principal axis. After refraction from the lens, now here at this point the refraction will take place and this ray will get diverged because concave lens is a diverging lens, you know, from the 10th class. These rays are getting diverged like this. These rays are getting diverged like this. Okay. Now it's fine. Now it's fine. Getting diverged. And when you will produce these diverging rays backward, will meet at a common point known as the principal focus. Known as the principal focus. What is F2? F2 is the principal focus. Or second focus. Now there is one more term, focal length. There is one more term, focal length. Earlier also in case of mirror we have focal length. So focal length in case of the mirror is the distance between the pole. Focal length in case of mirror is a distance between the pole and the focus, the focal length. Here also in this case the distance between the optical center, O is the optical center here. Okay, you can just mark it. You can write this as a optical center. So the distance between the optical center and the focus is known as the focal length. So you can write the distance between focus and optical center is focal length. Focal length can be negative, focal length can be positive. We will discuss. Remember one point, again and again I am telling, distance measured in the direction of the light is positive. Distance measured in the direction of light is positive. Distance measured in the opposite direction of the light is negative. Another point. All distances will be measured from the optical center. All distances are measured from optical center. From optical center. Earlier in case of mirror, all the distances are measured from the pole. Here all the distances are measured from the optical center. Now one by one we will see what will be the focal length. One by one. We should choose a color. This color, I think it will be fine. This will be fine. Okay. So now the distance between the optical center. So first draw a vertical line. I think it will be better to show that. So this is the optical center. This is a vertical line. You can draw a vertical line, okay, to show the optical center. And whenever you are drawing a diagram in exam, scale should be there. This is the optical center here. Here is the optical center. This, in this case, optical center is this. Optical center is this. Okay, so I think I have written, I think somewhere, O is the optical center. Now, what is focal length? Two focal length will be there. So for this case, the focal length will be the distance between the optical center and the focus. This is the focus. So this distance, you can say, will be the this distance, na? From the optical center to the focus. This distance will be the focal length, that is small f1. Okay, focal length is represented with small f. Focal length is represented by small f, earlier also we have seen. Okay, now positive or negative decided by the direction of the incident ray. So incident ray is in this direction. Incident ray is in this direction. In this direction, there will be incident ray in this direction. And you are measuring the distance in this direction, means this focal length will be f1 will be negative. Here in this case, the focal length will be this distance. Will be this distance, na? Distance between the pole and the focus. So this will be f1 and this will be negative or positive. This will be positive because this is measured in the direction of the incident ray. Incident ray is coming in this direction. Now see this, very important. The distance between the optical center and the principal focus is focal length. So this distance will be the focal length. That is, you can say this is f2. And this will be positive. Why positive? Because we are measuring in this direction, in the direction of the incident, right? Now here, what will be the focal length? This distance. So this will be the focal length, f2. This will be negative. So in case of concave lens, the focal length is negative. In case of convex lens, the focal length is positive. But if you are talking about the first focus and the second focus, so for a minute, just forget this two, these two. Remember these two. If the focal length of a lens is positive, then it will be a convex lens. If the focal length of a lens is negative, then it will be a concave lens. Okay, in this way you have to remember. This will be also the focal length, but we define focal length in this way. Fawaz, Nida and Hamza understood? Okay. Take the screenshot. Fawaz, tell me one thing. During the class, from the starting, anywhere is my voice is breaking or my video is breaking, or is it, or it is all
No,
right?
sir.
Hmm?
No, it's not breaking.
Sir, it's not breaking.
Not breaking up? Okay. Then you can take the screenshot. So in this way, you will decide the focus and focal length. So these are very basic things, but these are also at the same time, these are also very confusing things. So I told you the reason behind each and everything. And now depending upon you, how much you have understood. Okay. So Fawad and Hamza, not breaking na? Voice is okay na?
Yes, sir.
Okay, fine. Please take the screenshots and at the same time, what you have to do, arrange the screenshot in a proper order. Okay. Because these notes are very important. Scroll down, Nida. Okay. In 10th also we have only the principal focus. There we do not study the first focus. Means we study the first focus, but mostly we are focused on the principal focus. Okay. Now see all of you. Again, I am telling. See, uh, if someone is asking, what is the principal focus in case of the convex lens? Okay. If someone is asking, then not someone is asking. If examiner is asking in the exam, then what you will say? Light rays parallel to the principal axis. Light rays parallel to the principal axis after refraction from the convex lens. After refraction from the convex lens, meet at a common point on the principal axis. Meet at a common point on the principal axis, and that common point is known as the focus. Okay. That common point is known as the focus. Remember? Once again, I am repeating. Light rays parallel to the principal axis after refraction from the convex lens meet at a common point on the principal axis known as the principal focus. For the concave lens, the story will be different. Light rays parallel to the principal axis after refraction from the lens getting diverged, and these diverging rays when produced backward meet at a common point on the principal axis known as the principal focus. So Fawad, can you define means in the exam, Nida? Should I write the definition, or I think you can uh, means uh, define by yourself?
Sir, can you write this for concave lens?
Hmm?
So can you write for concave lens?
For a concave lens. I'm writing for both the lens. Again, you have to take the screenshot for that. No problem. We can write it.
Yes, sir.
Okay. You can say light rays parallel to principal axis, okay, after refraction from convex lens, okay, meet at a common point on principal axis known as principal focus. Okay. Okay. Now for the concave lens, we can write light rays parallel to principal axis. Now see, light rays parallel to this is the principal axis, and these are the light rays, and these light rays are parallel to the principal axis. So you can write light rays parallel to the principal axis after refraction from which lens? Concave lens. Concave lens are diverged okay. Now you can see parallel, and after refraction from the lens, these rays are getting diverged because concave lens is a diverging lens. That is why the concave lens is known as the diverging lens, because parallel rays getting diverged. So after refraction from the concave lens are diverged, then after that you will say these diverged rays, or you can say diverging rays, when produced backward meet at a common point known as principal focus of concave lens. Focus of concave lens. Here you can write principal focus of convex lens. Now again you can take the screenshot of this part. Just wait, just wait. Take the screenshot. Again, Hamza, you also. Okay. Okay, after this, now very small topic we have, and then we will wind up this class. Uh, Earlier also we have seen this type of topic, rules for image formation by the convex lens. So this is a convex lens, and this is the optical center. Okay. Okay, good. But just I am finishing this in 4 minutes. Then you can leave. In 4 minutes I am just
Okay.
finishing it.
Okay.
This O is the optical center. So this is the principal axis. And this is the convex lens. First rule is, if a ray of light is passing from the, this rule we already know. If a ray of light is passing from the optical center, it will pass straight. Finish. Second rule, if a ray of light is parallel to the principal axis, if a ray of light is parallel to the principal axis, it will pass from the focus after reflection. Means second focus or principal focus. And this is the optical center. Another last rule. If a ray of light is passing from the first focus, after refraction from the lens, it becomes parallel to the principal axis. Okay, this is the principal axis. So we have only these three rules, and obviously we will use only these two rules to form the image. Okay. Okay. So write down, take the screenshot. Okay. All of you. Nida, Hamza, and Fawaz, all of you take the screenshot. Done. Nida completed. Okay, very good. This one. Okay. This one. Okay, Fawaz and Nida and Hamza. So now in the next class, we will discuss the image formation by the convex lens and concave lens, and we also discuss the lens maker formula. Okay, so we will now meet in the next class. Till then, revise your notes properly and arrange your screenshots in a proper sequence. Okay. Okay.
Okay, sir. Thank you.
Assalamu alaikum.
Walaikum. Okay. Okay, fine. Okay, in the first question, this question, this one. Okay, tell me, what is the doubt? Mm, hmm. You are right, but now here what is happening? You are right. The real and virtual image can be given by the magnification, or I think you are saying that. But here the object is very point object. Point object means very small object. So for very small object, the height of the object is almost negligible. So magnification here will not work. Okay. Here magnification will not work in this case. Here the object is very, very small here. Okay. So if this object is supposed like this, of this type of length. So in that case, we can define above the principal axis, there is height positive, and below the principal axis, the height is negative. So basically the magnification, that concept na, is valid generally for the mirrors and also the lenses.